Good morning to all of you. Welcome back. Please go to this website mobilefish.com. Those who have gone to this website, please come to the chat box and say yes. Please go to mobilefish.com. There are hash generation services there. Please generate hash of your name using SHA 256. Generate hash. Hello? Nikhil is there? Nikhil Murli from AC department. Rachita.
Yes, sir.
Please, have you gone to this link? Mobilefish.com.
Yeah. Yes, sir.
Please generate hash of your name. See in this link, there is a brief description given with respect to MD5, SHA1, SHA224 and SHA256. So here just a simple task is to use SHA256 algorithm, which is a cryptographic hash function designed by National Security Agency NSA. SHA256 produces a 256-bit hash value, okay, which is typically given as a hexadecimal number, 64 digits long. So please generate, come here, hash generator input. You can give some name, give your name, say, I'm giving my name, Arun Kumar, and this is the input. Now you generate hash. So now in fact, the hash is generated for MD5, SHA and SHA256 also. This is the hash generated. Like Prashant or has put in the chat box, I request all of you to put your hash of your name in the chat box quickly. Sadeh Kumar, put your SHA256 hash of your name in the chat box. Pooja also. Anjan Guru Prasad, please put your hash of your name using that is generated using SHA256 in the chat box. I am getting only 2 responses. What about others? Pooja, Lavanya, Sadev Kumar, Murugesh Naidu, Rachita. Quickly, those who did not generate the hash, please generate the hash and mention your hash value in the chat box. Quickly, only 4 responses. What about others? Okay. So in this, those who are not yet gone to this link, please go to mobilefish.com services hash generator. So in this, go back to the input. Arun space Kumar, just add a hash or say some dollar to this, generate again the hash, compare the hash of your name and again hash of your name added with the dollar. Just write in the chat box whether they are one and the same. Yes or no? Yes or no, please write in your chat box. When you generate hash of your name using 256, you got some hash value. Now for your name, you are adding dollar or any some other special character or even a space. Now compare the hash value that you generated second time. Some answers quickly. Pooja is available.
Yes,
Hello.
sir.
You got the hash?
Hello. Yes, sir.
you added the dollar to the name, and again you generated the hash using SHA-256.
Yes, sir, I generated. And the number is changed, sir. We didn't got the same.
Is it same or different? Pooja?
Different, sir, different.
Different.
Different, sir.
Okay. So please write in your chat box it is different. So if it is same, write yes. Otherwise, you can write different or no. Quickly in the chat box. Okay. I hope you understood the difference. So MD5, SHA-256, SHA-224, these are different algorithm with respect to the generation of hash is concerned, and a small change in a character or adding a character, a space or a special character to your name has made a change, brought a drastical change in the hash value. This understanding is important for us to continue the discussion of the blockchain concept. Come back to this slide. Understanding SHA-256 hash. This is a hash value generated of a block. If the blockchain is of a Bitcoin blockchain has consisting of sender details, receiver details, and number of bitcoins to be transferred, for example. Now this information is the input for the hash algorithm, say SHA-256, and a hash is generated like this. Just now how we have checked it in the website of mobile face, right? So a block also has a hash. It can be understood as a fingerprint which is unique to each block. It identifies a block and all of its contents, and it is always unique, and just like a fingerprint. So once a block is created, any change inside the block will cause the hash to change. That's very, very important, right? Therefore, a hash is very useful when you want to detect changes to intersections. If the fingerprint of a block changes, it does not remain the same block. Each block has data. Each block has hash and hash of the previous block. Therefore, remember, each block is consisting of data. Each block is consisting of hash and hash of the previous block. Consider the example given here, where we have a chain of 3 blocks, block 1, block 2, block 3. The first block has no predecessor. This is the first block created. This is also called as genesis block. Hence, it does not contain the previous block. Block 2 contains the hash of the block 1. Block 2 contains the hash of the block 1. You can see here, hash of block 1 is 2ZB1. So block 2 contains its own hash as well as hash of the previous block. So hash of the previous block for block 2 is 2ZB1. That's there, right? Similarly, hash of the block 2 is 7B2Z, and this is previous hash for the block 3. This is how we'll be having the blockchain. Hence, all blocks are containing hashes of previous blocks. This is the technique that makes a blockchain so secure, right? Correct? Let's see how it works. Now, think of a situation where attacker thinks of changing some contents of data present in the block 2. Correspondingly, the hash of the block also changes, but block 3 still contains the old hash of block 2. This makes block 3 and all succeeding blocks invalid as they do not have hash of the previous block. Right? Try to understand this. And cyber attacker can change any block content as he wants? No, because if he changes the content, hash value changes, right? Just now you have seen that. So if he changes block 2, block 3 and succeeding blocks becomes invalid as they do not have correct hash of the previous block. Right? For him it becomes invalid. Therefore, changing a single block can quickly make all the following blocks invalid. Right? Invalid. Proof of work. This is a very important concept that you need to understand with respect to the blockchain. Hashes are an excellent mechanism to prevent tampering, but you know, these days you are having high-speed computers, right? It can calculate hundreds or thousands of hashes per second. So in a matter of few minutes, an attacker can tamper a block and then recalculate all the hashes of the other block and make other blocks are also valid. As we have shown here, we said if an attacker makes a block 2, some changes in block 2, hashes of block 2 and block 3 and succeeding blocks changes. Now, suppose a set of nodes involved in the blockchain are powerful computers. In a matter of few minutes, an attacker can tamper with a block and then recalculate all hashes of the other blocks to make the blockchain valid again. This is very dangerous situation. Therefore, blockchain concept, blockchain technology brings the concept of proof of work. This is a mechanism which slows down the creation of the new block. Once you are allowed to create a new block, then quickly you will create the hash of the other blocks and you quickly can make in a matter of few minutes all blocks valid and you can done your work, right? So to avoid this, there's a concept brought by the blockchain technology called proof of work. A proof of work is a computational problem that makes certain effort to solve the problem, but the time required to verify the results of the computational problem is very less compared to the effort it takes to solve the computational problem itself. Right? The creating a block may be quick, but solving this puzzle takes time, right? And here you have to understand this problem with an example. In case of a Bitcoin, it takes almost 10 minutes to calculate the required proof of work to add a new block. Suppose a node wants to add a block to the chain, then it has to solve a certain puzzle. To solve a certain puzzle, it takes about 10 minutes. If a hacker would to change the data in block 2, he would need to perform proof of work, which takes 10 minutes, and only then he can change in block 3 and all the succeeding blocks. Right? So if he wants to change in block 2, he has to perform proof of work, and only then can make the change in block 3 and all the succeeding blocks. So takes a lot of time here. So if you want to make any changes, right, then there will be a lot of time consumed. This kind of mechanism makes it quite tough to tamper the blocks to blocks. So even if you tamper with even a single block, you need to recalculate proof of work for all the following blocks. So if you make changes in the second block, okay, and if you are having 100 blocks in the remaining, so second block, anyway it has to be done. Genesis block, no changes. So n-2 blocks you have to make the changes. So thus hashing and proof of work mechanism makes a blockchain secure. See the mechanism, how it brings the security. There is one more a model which brings the blockchain a security called a distributed peer-to-peer network model. Distributed peer-to-peer network model. There is one more. This model secures themselves. That's by being distributed. So what we have seen is a kind of a chain kind of blockchain, right? But here you are seeing at the different architecture, distributed architecture. Instead of using a central entity to manage the chain, as in the previous case, blockchain is just a distributed peer-to-peer network, and everyone is allowed to join there. When someone enters the network, he will get the full copy of the blockchain. Each computer is called a node here. Each computer is called a node. Every node will get the copy of the blockchain. Please understand this. There in the previous case, here in this case, every block is not having the copy of the entire chain. Okay, it's not that it depends on the model. So in this model, it is not having the copy of the entire blockchain. Coming to the distributed model, so here you will be having every node will be having the full copy of the blockchain. Please remember the difference in a distributed peer-to-peer network blockchain, right? A node will be having the full copy of the blockchain, and each computer is called a node. See here. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Distributed peer-to-peer network. Okay, let us see what happens now in a distributed peer network. When a user creates a new block, this new block is sent to all the users on the network. All the users on the network. Each node need to verify the block to make sure that it has not been altered. It has not been altered. After complete checking, each node adds this block to their own blockchain. Okay, own blockchain. So this is the difference. So you can see here 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. 4 is added, new block is added everywhere. There are 4 users here. Every user has got a blockchain. So this user, let us say, user X has got this blockchain. User Y has got this blockchain. User Z has got this blockchain. X, Y, Z. Another one, user A has got this blockchain. Every user has got the blockchain. When a new block is created, every user validates that block. Every user validates the block, and each node adds this block to their blockchain. All these nodes in the network creates a consensus. Consensus is like an agreement. They agree about what blocks are valid and which are not valid. Okay, they will be knowing. They will come to a common agreement. So yes, this block can be added because it is valid block. Nodes in the network will reject blocks that are tampered with. If somebody has tampered, if some changes have been done or tampered, okay, then the nodes will reject the block. So to successfully tamper with a blockchain, you will need to tamper with all the blocks on the chain, redo the proof of work for each block. Is it practically possible to tamper all the blocks? Because if you tamper one block, you have to tamper all blocks, and you have to redo the proof of work for each block. That concept has been brought in, right? Simply you will not be allowed to create a new block. First you have to do proof of work. That means a computational problem you have to solve. You have to solve some puzzle. So in case of Bitcoin, it takes 10 minutes. So first you redo the proof of work, then create the block, then for that block create the hash, and go to third block and redo the proof of work, create the hash. That way you have to do for all the nodes in the block, in the blockchain. So this is at least to take control of the peer-to-peer network. 50% of the nodes have to be worked on. Okay, that's right. To take control of greater than 50%, that means 51% is greater than 50%. You should have at least 51% of the peer-to-peer network blocks should be under your control. After doing all this, your tampered block become accepted by everyone else. This is next to impossible task. Hence, blockchains are conceptually secure, I will say, because these are all the concepts what we are talking, but practically something may change, and we should be able to have the mechanism for to face such problems. How blockchain transaction works? Okay, we have to see this. So very first you can see here, transaction requested, broadcast the transaction, validate the transaction, add blockchain. So now in the distributed peer-to-peer network, we said a new block is created and it will be added. How that process happens actually, how transaction happens. Some person requests a transaction. The transaction could be involved cryptocurrency or some contracts or records or other information. Okay, please be patient, because this technology you need to understand. You have to read, you have to go through some case study, you have to go through different tools like Hyperledger, Ethereum tool, then you will completely understand. So it takes some time. You have to involve in the process of understanding. Okay, some person requests a transaction. The transaction could be involved cryptocurrency, for example, smart contracts, for example, records or other information, for example, records. So we will be explaining you land record transaction use case. So we will be elaborately presenting that. So if, for example, in this case, some land records. So registration process, for example, sub-registrar registers the land belonging to some people, from the seller to the buyer, right? So then records may be having certain informations. It requires for the transactions. So registration of the records. Requested transaction is broadcasted to a peer-to-peer network with the help of nodes, for example. Right? The network of nodes validate the transaction and users status with the help of known algorithms. Once the transaction is complete, the new block is then added to the existing blockchain. Transaction after the transaction is completed, because before the transaction is completed, you cannot add. Once you add, it becomes immutable. You cannot change any content of it. Therefore, once the transaction is completed, then it is added. So the blockchain transaction works in this sequence: request for transaction, broadcast the transaction, validate the transaction, then add to the blockchain. This is how it happens. Now let's go to this point. Why do we need blockchain? So we have seen, I think this is the right time to summarize why do we need blockchain. Because of certain important points, the blockchain has become so popular today. So banking sectors uses the blockchain, different sectors uses the blockchain, supply chain management, in that you'll be using the blockchain. I'll explain you through different use cases how blockchains are useful. Resilience, for example, blockchain is often replicated architecture. The chain is still operated by most nodes in the event of a massive attack against the system. Resilience, because the chain is redundant. See, chain is redundant, often replicated architecture. Time reduction in the financial industry, blockchain can play a vital role by allowing the quicker settlement of trades assets, trades. Okay, and see that is actually a lengthy process for of verification. Verification is a lengthy process, trade assets. So in such cases, a verification, settlement, and clearance takes a longer period of time. Once you are having this type of process in place, so we can assume that the records are not changed at any point of time, and a single version of the agreed upon data of the share ledger is available between all stakeholders. Everybody will be having the record, the same record. So that way, time reduction happens during the settlement of some bills. Reliability, blockchain certificates and verifies the identities of the interested parties. This removes double records, reducing rates, and accelerate transaction. Unchangeable transaction. By registering transactions in chronological order, blockchain certifies that unalterability exists. Okay, if any changes happens in a block, a new block is added. For that, new hash will be created. So therefore, transactions cannot be changeable. A new transaction can happen, and certifies unalterability of all operations, which means when the new block has been added to the chain of ledgers, it cannot be removed or modified. Okay, that is the nature of the blockchain. This nature of the blockchain can prevent frauds, fraud prevention, concept of shared information, and consciousness prevent possible losses due to fraud or in logistics-based industries. Blockchain as a monitoring mechanism act to reduce cost. Transparency, changes to public domains, changes to public blockchains are publicly viewable to everyone. This offers greater transparency and all transactions are immutable. Collaboration, allow parties to transact directly with each other without the need for mediating third parties. Decentralized, there are standard rules on every node exchanges the blockchain information. This method ensures that all transactions are validated and all valid transactions are added one by one. Therefore, to summarize, blockchains are needed, are popular today because of resilience, time reduction, reliability, unchangeable transactions, fraud prevention, security, transparency, collaboration, and decentralized nature. These are the typical characteristics of a blockchain, which brings the blockchain technology in the forefront of cybersecurity. Now we'll go to the blockchain versions. Blockchain versions, blockchain 1.0, blockchain 2.0, blockchain 3.0. These are the different versions. Blockchain 1.0, it is a currency, the implementation of distributed ledger technology, which led to its first and obvious application of cryptocurrencies. This allows financial transactions based on blockchain technology. It is used in currency and payments. Bitcoin is the most prominent example in this segment, right? So far, up to 2020, Bitcoin or cryptocurrency was not valid in India. Now, the Supreme Court has told it is valid in India also. Up to that, it was a question, right? Question mark. Now again, since the Supreme Court has told it is a valid one, the law, IT law, right? IT Act, Cyber Law has to learn this and have a different act or section for dealing with the cryptocurrency problems or cases. Now go to blockchain 2.0, smart contracts. So the new concepts of smart contracts, small computer programs that live in the blockchain, they are free computer programs that execute automatically and check conditions defined earlier, like facilitation, verification, or enforcement. It's used as a replacement for traditional contract. So smart contract, what is a smart contract? It's an e-contract, for example. It's an e-contract. You cannot deviate from the contract, similar to the regular contract, but there are free computer programs that execute automatically and which are designed, which are written, the logic of the programs are written as per the conditions of the smart contract and check the conditions defined earlier like facilitation, verification, or enforcement. So what is contract? So suppose if I have ordered for some mining ores of the diamond, the quality of the diamond, for example, with respect to that, I may be having a smart contract, right? Our computer program should be able to verify whether the supplier is supplying the mining ore of the diamonds as per the agreed contract or not. So to implement such blockchains, we'll be using blockchain 2.0 version for the smart contracts. The third type of blockchain version is blockchain 3.0 called DApps. DApps is an abbreviation of decentralized application. It has their backend code running on a decentralized peer-to-peer network. Okay. So a DApp can have front-end code and user interfaces written in any language that can make a call to its backend like a traditional apps, blockchain DApps. Okay. Now, blockchain variants, coming to the blockchain variants, the public blockchain, private blockchain. Mainly, we classify the blockchain into public blockchain. It's in this type of blockchain, ledgers are visible to everyone on the internet. It allows anyone to verify and add a block of transaction to the blockchain. Public networks have incentives for people to join and free for use. Anyone can use a public chain network. Private chain is within a single organization. It allows only specific people of the organization to verify and do the transaction blocks. However, everyone on the internet is generally allowed to view it. So for example, if a university implements a blockchain to maintain the records of the students, especially the degrees awarded using the blockchain, it will be more secure and it becomes a private blockchain. Only the concerned responsible authorized persons like vice chancellor, okay, and registrar, dean, directors, principals, examination section concerned people can only participate in this blockchain. Of course, students can participate. Even though it is visible, the validity of the blocks, transactions will be done by only agreed people, only accepted people. Now, there is one architecture here. So blockchain across departments, how we can have the blockchain. So department A, department B. So these are the nodes, and here is one node which renders some services. Here is one node which renders some services. In this blockchain variant, only a group of organizations can verify and add transactions. Here the ledger can be open or restricted to selected groups. Consortium blockchain is used across organization. It is only controlled by pre-authorized nodes. Blockchain use cases. So some of you were asking the examples of the blockchain. A lot of examples of blockchain are available. Blockchain technology is used widely in different sectors, in markets, for billing information, for monitoring and data transfer, right? In supply chain management, so blockchain is used. In government sectors, voting, proposition P2P bond, registration of documents, IP registration and exchange, intellectual property registration and exchange, tax receipt, notary service, and document registry. So here, the government sectors, the blockchain finds this application. In IoT, agriculture and drone sensor networks are used are using the blockchain. Smart home networks uses the blockchain, right? So there are many use cases given with respect to the blockchain. Health, so there for the data management purpose, big health data stream analytics, digital health wallet, smart property, health token. In these cases, the blockchain is used. So different use cases are given here. Finance and accounting, especially here it is important. Digital currency payment and remittance, de-cartelized capital marketing using network of the computer and the blockchain. These are the certain things used with respect to the blockchain use cases. Let's go into certain real-time life use cases of the blockchain. The Dubai Smart City in the year 2016, Smart Dubai office introduced a blockchain strategy. Using this technology, entrepreneurs and developers will be able to connect with investors and leading companies. The objectives is to implement blockchain-based systems which favors the development of various kinds of industries to make Dubai the happiest city in the world. Okay. The second real life use case of the blockchain is instant customer retention. Instant is a consumer retention as a service based on the blockchain technology. It's a royalty program which is based on generating token for business affiliated with its related network. In this system, blockchain is exchanged instantaneously and it can be stored in digital portfolios of a user's phone or accessing through the browser. Hello? So you're getting understanding blockchain use cases. What are the different applications of the blockchain use cases? You're getting right? I hope all of you are listening to the explanation. Can you tell me one important, most popular application of the blockchain? Can anybody type? Please type the popular application of the blockchain in the chat box. Please type the popular application of the blockchain quickly. Hello? Anjan Guru Prasad? You are there?
Yes, sir.
Anjana, can you please type the popular application of the blockchain in your chat box? Okay, Bitcoin currency, very good. One more application of the blockchain technology. Sai Karthik.
Yes, sir.
Please type one application of the blockchain technology apart from this cryptocurrency. Fine. Healthcare, real estate, good. In a blockchain, suppose there are 50 nodes. If cyber attacker tamper fifth node, then how many other nodes are to be made valid? Please write your answers in the chat box. Write the number quickly. In a blockchain, suppose there are 50 nodes. If you are cyber attacker, if a cyber attacker tamper fifth node, then how many other nodes are to be made valid? Please write your answer in the chat box. Write the number. Please write your answers quickly. Answers should come in the chat box. Suru Shashank. Suru Shashank is there? Suru Shashank. Sahadev Kumar. Sahadev Kumar, are you present? What is the answer for this question? Seema is there? Seema from MCA. Sneha from CSC is there? Hello? Likita from AC? Can you answer? You are present or not?
Yes, sir.
Can you understand this problem?
Yes, sir.
So what is this problem? Can you please explain this problem? In a blockchain, suppose there are 50 nodes. The problem, can you please explain and give the answer? Chetana from MCA, please write your answer. Sai Karthik. Sai Karthik.
Yes, sir.
Please write the answer for this question. You understood this question? I got one answer in the chat box. Sai Karthik, do you think what answer given is correct?
Yes, sir. Because the hash of one thing is stored in the other block, no, sir.
Yes, yes.
So alternate hashes changes, so the next 45 will be not working.
Yes, remaining 45 becomes invalid, and the attacker is supposed to now calculate hash and even proof of work for remaining 45 nodes.
Yes, sir.
Is it correct?
Yes, sir.
Okay, thank you. So I have asked to mention one famous applications of the Bitcoin blockchain, that is cryptocurrency. Most of you may be knowing what is a cryptocurrency. As we can say, cryptocurrency is one medium of exchange like traditional currencies such as rupee or US dollar, but it is designed to exchange digital information through a process made possible by certain principles of cryptography. Cryptocurrency, as you know, is a digital currency, okay, and is classified as a subset of alternative currencies and virtual currencies. Cryptocurrency is now it has become like an instrument based on digital cryptography. In this kind of cryptocurrency, the holder has the currency the holder has of the currency as ownership, no other record kept as the identity of the owner in the year 1998. Money, B money, right? Uh, and an anonymous distributed electronic cash system. The very first the cryptocurrency word is coined by Wei Jai, published. His name is WEIDI. Wei Jai published in 1998 this concept. So most popular question is what is a Bitcoin and how the blockchain has been was evolved. So Bitcoin was launched in 2009 by an unknown person called Satoshi Nakamoto. Bitcoin, even we do not know whether it is his real name or not. So it is only known, not person is not known, unknown person, but name is known. Bitcoin is a peer-to-peer technology which is not governed by any central authority or banks. Currently issuing Bitcoins and managing transactions are carried out collectively in a network. It is presently the dominant cryptocurrency of the world. It is open source and designed for the general public, means nobody owns the control of the Bitcoin. In fact, there are only 21 million Bitcoins issued currently. Bitcoin has a market capital of $12 billion. So this is some of the information with the Bitcoin, friends. You need to know some of the information with respect to the Bitcoin. Anyone can use Bitcoin without paying any process fees. If you are handling Bitcoin, the sender and receiver transact directly without using a third party. The blockchain is the technology behind the Bitcoin. Bitcoin is the digital token, and blockchain is the ledger that keeps track of who owns the digital tokens. You cannot have Bitcoin without blockchain. You can have blockchain without Bitcoin. That all these things we discussed. Other prominent cryptocurrencies are Ethereum, Bitcoin Cash, Ripple, and Littlecoin. These are the other cryptocurrencies apart from the Bitcoin. Okay, so please remember them: Ethereum, Bitcoin Cash, Ripple, and Litecoin. These are the other cryptocurrencies. So now we'll come to some discussions with respect to the so blockchain versus shared database. So blockchain and shared databases, here you can find the blockchain, and here central is just the authority, which is a data shared database. Okay, so now we'll have quickly the differences or comparison of blockchain to the databases. A blockchain insertion operation we can do, but no deletion operation can be done on the blockchain. Shared database, you can create the shared database, you can read, update, and delete. All these things can be done on the shared database. Replication, with respect to the replication parameter, full replication on every peer. Okay, that is possible, full replication on every peer. Because if you take a distributed peer-to-peer architecture, a copy of the blockchain is maintained by with every user. But in case of shared database system, master-slave and multi-master concepts are possible. Consensus algorithm, most of the peers agree on the outcome of the transactions. So in case of shared database, distributed transaction which helped in two phases, commit and Paxos, right? So validation, global rules enforced on the world blockchain system offers, in case of shared databases, offers only local integrity constraints, right? Confidentiality in blockchain, fully confidential. In case of shared database, not totally confidential. Robustness, fully robust technology. but in case of shared databases, not entirely robust. These are some of the things which gives the comparison of the blockchain with the shared database. Myths about blockchain. It solves every problem. It's a myth. In case of a blockchain, right? Trustless technology, secure, and smart contracts are always legal, right? Immutable, need to waste electricity, it is inherently unusable. It's not, it solves every problem, is a myth. Blockchain is also like a database. It can shift trust, also spread trust. It focuses integrity. It focuses on integrity, right? So there is some of the things. We'll go to the limitations of the blockchain technology. Limitations, as every technology has got limitation, even the blockchain has got the limitation. Higher costs, nodes seek higher rewards for completing transactions in business which work on the principle of supply and demand. Nodes seek higher rewards for completing the transactions in a business. So this is one limitation. Slower transactions. Nodes prioritize transactions with higher rewards. Backlogs of transactions build up. Smaller ledger, it's not possible to fully copy of the blockchain potentially, which can affect immutability and causelessness. So it is, even though we say full copy of the blockchain is maintained, it's difficult, right? To maintain a smaller ledger can be maintained. Transaction costs and network speed also matters. Transaction cost of Bitcoin is quite high after being, right, computed as nearly free for the first 5 years. Network speed is also important because without internet, the blockchain cannot work. Risk of error involves, there's always risk of error as long as human factor is involved in case of a blockchain. Blockchain serves as the database. All the incoming data has to be of high quality. However, a blockchain serves as, however, the human involvement can quickly resolve the error. It's possible. But the human involvement leads into certain error also. At the same time, human intervention is required to see the quality of data. Wasteful, every node that runs the blockchain has to maintain constantness across the blockchain, right? So we think there are many memory cycles, energy cycles are wasted because very low, this offers very low downtime and makes data stored on the blockchain forever unchangeable. However, all this is a wasteful. In order to make the bring the immutability, right? You have to add a new block, for example, and a lot of proof of work, a lot of computational power will be wasted. And if there are 1,000 nodes and in a blockchain, and if there are 1,000 users, then see the computational power involved while creating a new block. So there is a wasteful of resources, this, which is the limitations of the blockchain technology. At the end, we'll summarize the entire thing, whatever we studied since morning. A blockchain is a chain of block that contains information. The blockchain is not a Bitcoin, but it is the technology behind Bitcoin. Every block contains hash, and every block has a hash of the previous block. changes in the content, a small change in the content of a block results in the drastical change in the hash, that is the outcome of the hash algorithm. Blockchain requires proof of work before a new block is added, because if you allow quickly to create a new block, it can quickly revalidate all new blocks and further subsequent blocks also. So for that purpose, blockchain has brought in the concept of proof of work. So before a new block is added, proof of work has to be executed by a particular block. The blockchain database is distributed. Blockchain is also a database. Blockchain is a distributed database among multiple peers, and it's not centralized actually. Blockchain technology is resilience, decentralized, time reducing, reliable, and it offers unalterable transitions. There are three versions of the blockchain. Blockchain 1.0, that is currency. Blockchain 2.0 for small contracts, and blockchain 3.0 for DApps, development of apps. The blockchain is available in three different variants: public, private, and consortium. These are the three variants of the blockchain. Higher cost, slower transactions, small ledger, the risk of error are some disadvantages of using the blockchain technology. We have many use cases of blockchain technology. In the real estate, it can be used. In the smart contracts, it can be used. In the land registration system, it can be used. We studied the Dubai, the smart city case of 2016. Instant customer retention system uses the blockchain. Blockchain for humanitarian aid are some of the real life use cases of the blockchain. Bitcoin uses the blockchain technology, which is not governed by any central authority or bank, but cryptocurrencies are said valid. We have to see really how actually it is valid. This is with respect to the basics of blockchain technology. Hello. So this completes basics of blockchain technology. Before going to explain the blockchain technology use case, some more information we need to discuss. Hello? Are you available? Hello. Hello. I request all of you, all the participants, please write your full name and USN quickly. Please note that we have not yet demonstrated the blockchain use case. So since I have to explain some more concepts of the blockchain, and then I want to go to the use case to practically demonstrate how a project of blockchain can be done. So I'll not be doing now. I shall be scheduling, I request some more time. So that I'll be doing, I will tell you the schedule when I'll be doing. As of now, after this uh, entry into the chat box from all the participants, then I'll go to some small video and I'll be giving that task. Okay. Please be online.
viruses, worms, and Trojan.
Hello? I request all the participants to watch this video and identify the difference between virus, worms, and Trojan horse. I repeat, I am requesting all the participants to do this small exercise and write in your chat box the difference between virus, worms, and Trojan horse after watching this video. Okay? Hello?
Trojan horses are all malicious programs that can cause damage to your computer, but there are differences among these three. What is a virus? A computer virus attaches itself to a program or file, enabling it to spread from one computer to another, leaving infections as it travels. Like a human, viruses, worms, and Trojan horses are all malicious programs that can cause damage to your computer, but there are differences among these three. What is a virus? A computer virus attaches itself to a program or file, enabling it to spread from one computer to another, leaving infections as it travels. Like a human virus, a computer virus can range in severity. Some may only cause mildly annoying effects, while others can damage your hardware, software, or files. Almost all viruses are attached to an executable file, which means the virus may exist on your computer, but it actually cannot infect your computer unless you run or open the malicious program. It is important to note that a virus cannot spread without a human action, such as running the infected program. So what is a worm? A worm is similar to a computer virus by design and is considered to be a subclass of virus. Worms spread from computer to computer, but unlike virus, it has the capability to travel without any human action. The biggest danger with a worm is its capability to replicate itself on your system. So rather than your computer sending out a single worm, it could send out hundreds or thousands of copies of itself, creating a huge, devastating effect. One example would be for a worm to send out a copy of itself to everyone listed in your email address book. Then the worm replicates and sends itself out to everyone listed in each of the receiver's address book, and the manifest continues on down the line. Due to the copying nature of a worm and its capability to travel across networks, the end result in most cases is that the worm consumes too much system memory or network bandwidth, causing the web servers, network servers, and the individual computers to stop responding. So what is a Trojan horse? The Trojan horse at first glance will appear to be a useful software, but will actually do damage once installed or run on your computer. Those on the receiving end of the Trojan horse are usually tricked into opening them because they appear to be receiving legitimate software or files from a legitimate source. Some Trojans are designed to be annoying, like changing your desktop, adding silly active desktop icons, or they can cause serious damage by deleting files or destroying information on your system. Trojans are also known to create a backdoor on your computer that gives malicious users access to your system, possibly allowing confidential or personal information to be compromised. Unlike viruses and worms, Trojans do not reproduce by infecting other files, nor do they self-replicate. So that's all about viruses, worms, and Trojans. If you like this video, please give it a thumbs up.
Please write any one difference among virus, worms, and Trojan horse. Quickly, I'm requesting all of you, and you can also refer if you want once again this YouTube video. Hello. Quickly write the difference between among virus, worms, and Trojan horse. Quickly, this is the quick one work. Please do it quickly. No answers? Please answer quickly. It indicates whether you are attentive or not at the side. Good. I got one answer. Prashant. Thank you. Sneha. Okay. Good answer. Good. Some more answers, please. Yashaswini from MCA, please write one difference. Sadhya Kumar, please write a difference. Seema, please write a difference. I hope Likita, Anjana are also present and write the differences in the chat box quickly. Hello? Only 2 answers? What about others? Okay, good, good. Prashant, Sneha, Anjana, Likita, Prashant Reddy, MCA. Prashant Reddy, please write. With respect to the Trojan horse also, you have taken only virus and worms to differentiate. Yashaswini, MCA. Virus and worms, okay. Trojan horse is not present here. Yashaswini, please write with respect to the Trojan horse also. Others quickly write. Getting some response, good. 32 participants are there, 32 responses minimum should be there, right? Can I expect some answer from Subramania Swarup? Mohammed David, please write your answer. Raksha K. Kumar, write your answer. Aditya, please write your answer. Spurti, write your answer. Good answer from Mehani MC. Gaurish, please write your answers. Quickly. I have sent you a link and also I have shown the video. If you could not see the video, at least now you see that video. The link is sent in the chat box. I'm just telling those who join now, please write a difference among virus, worms, and Trojan horse. Okay, those who answered can leave for today And tomorrow, regular as with respect to the regular schedule, we'll be having the class at open short-term course class at 10 a.m. tomorrow morning. Others, to consider them for attendance, everybody has to answer this question. So I'm once again informing all the participants to answer these questions. I can tell you, I have received answer from Prashant, Sneha, Anjana Guru Prasad, Likita, Prashant Reddy, Yashaswini, Umahani MCA, Subramanya Swarup, okay, Nidhi, Murugesh Naidu, Gaurish, Rachita, Apurva. From others, quickly answer within 5 more minutes. After that, I will be closing this session. And those who are answered can leave the meeting. Please join tomorrow at 10 a.m. So Professor Shivkumar from the MCA department will be demonstrating cyber security tools tomorrow. And I want to demonstrate, not tomorrow, but I will tell you when I will be demonstrating the use case of the blockchain. Okay. So please just go through different concepts what we have discussed today with respect to the blockchain. So quickly, others has to respond. Ashwini, you have not told about Trojan horse. Pooja K MCA, please send your answer quickly. Spurti can take 2 more minutes and answer. Those who answered can leave the meeting. Join tomorrow at 10 a.m. Have your laptop in place so that you'll be able to do some practical sessions tomorrow. Pooja, you have written about worms can be replicated where Trojan horse cannot be replicated. Correct, sounds correct. But you have not written anything with respect to the virus. While you are differentiating, all these three should come under one line or one thread of differentiating parameter. Good that I received the answer from Spurti. Thank you, Spurti. You can leave the meeting, but please join tomorrow at 10 a.m.
Sure, sir.
Okay. Suru Shashank, I'm not having your answer in the chat box. Sinchana, have you answered?
Yes, sir.
Okay. If you have answered, you can leave the meeting, ma. You can join tomorrow, 10 a.m.
Okay, sir.
Okay, ma. Thank you. Suru Shashank, Trojan horse is a virus that is placed in a file of which is used to invade a system. You can say Trojan horse is a malicious program or a malware, but Trojan horse, we won't consider it as a virus. And Trojan horse, okay. Thank you. Ashwini from MCA, please answer.
Sir, I have answered, sir.
Okay. Thank you, all of you, for participating very actively. I request all of you to report by 10 a.m. tomorrow for the next session.
Okay, sir, thank you.
And tomorrow it is Thursday, right? All of you will be having very useful session tomorrow. Please join. Thank you, one and all.